2020 October, November, paper 11. Let's take a look at the question number 1. We have a matrix M and is given as the multiplications of two transformations over here, where the A and B are positive constant. The matrix M represents a sequence of two geometrical transformations. State the type of each transformations. Okay, so they are looking for type. So actually, there's no need for us to explain them in detail. Just mention the type will do. So the first type, this is actually the stretch. The second type over here is actually the shear. So you just need to mention that the A, but A is just say that this is a one-way stretch. Followed by a shear. So you do not need to, actually, it's not just necessary to explain them in detail because they just want to state the type of the transformations. However, if you explain them in the detail, in a more detailed way, that is fine, no problem. So now we take a look at B. We have a unit square. So unit square means the square is 1 unit, the area is 1 unit. Since it's a square, so it's actually 1 unit over here. So the area is 1. Is transformed by the matrix M onto the parallelogram OPQR. So from unit square to become OPQR. Find in terms of A and B the matrix which transform the parallelogram PQR onto the unit square. So this is the unit square. And if you transform to the OPQR, you are going through the matrix M. And if you want to transform from the OPQR, go back to the unit square, you have to be M inverse. So for this question, first of all, you need to find the product of the two matrices over here. So it's a 1, 0, B1, A, 0, 0, 1. If you multiply them, and then you will get this as the A0, B1. Then to find the M inverse, it will be A minus a 0. These two swap, these two put negative. Simplify it, you will get a 1 over A, 1, 0, negative BA. That is the answer for the B. Move on, we have a question C. It is given that the area of the image is a 2 cm square, and the line of x plus 3y is equal to 0 is invariant under the transformation under the transformation by M. Okay, so they mentioned to you that this is an invariant line. The x plus 3y equal to 0 is an invariant line. Find the values of A and B. So we start from here. These informations, they say that the area of image is equals to the area of is equal to 2 cm square. Okay, so the area of the OPQR is actually the determinant of M modulus multiplied by the unit square. Area of unit square. So for unit square, the area we know is 1 unit. So that means the 2 is equals to the modulus of, just now the determinant is A. So your A is a 2 because the A is positive. Okay, now we want to find the B. So to find the B, your invariant line, x plus 3y is equal to 0. You can make the x become negative 3y. So if for invariant line is a xy, transform to become x prime, y prime. Okay, so this is the matrix for M. is A, B, 0, 1. But since we have found the value A, we can straight away change the value A here become 2. Okay. We expand them, you will get 2x. Oh, okay. Before we expand them, we just need to make the x become negative 3y. X become negative 3y. This one will remain as a y. Same thing goes for the image invariant line. The x prime, y prime, the x prime will become negative 3y prime, okay, because it's invariant line. So the x prime will be negative 3y prime. So you expand them as usual, you get negative 6 plus the b multiplied by y is equal to the negative 3y prime. And the second part is the y equal to the y prime. So this part is not necessary. Oh, so sorry, it's necessary. It's necessary, yeah. Y is equal to the y prime because we want to find the b. I call this one equation 1, this one is equation 2. Just take the 1 divided by 2, you will get negative 6 plus b multiply y divided by y is equal to the negative 3y prime divided by y prime. So you cancel it, you get negative 6 plus b is equal to the negative 3. Therefore, your b is a 3. That is how you get the answer for the number 1. Move on, we have a question number 2. Use the formula booklet MM19 to show that the series over here can be expressed in the form of an cube plus the bn square and plus the cn, where the ABC are the constant to be determined. So for these questions, it's actually quite straightforward. All you need to do is to expand them carefully. So if you expand them, you get 49r squared plus the 63r plus 8. Then check the formula booklet, MF19. You can get this one as a 49 and n plus 1. Oh, not enough space. I spare more space over here. So it's equals to the 49 n plus 1 to n plus 1 over 6 plus the 63 n plus 1 over 2 plus the 8n. So to make our job easier, we try to factorize the n out first. That means I try to factorize the 1 over 6n. So if I factorize the 1 over 6n out over here, I get 49, 2n squared plus 3n plus 1. Then this one, it will be 189 n plus 189. And this one, it will be 48. So we make the expression inside here become quadratic. Okay. But if you don't factorize it out, it's still fine. Okay. Then after you expand and then simplify further, you will get this as a 98n squared plus the 147n plus the 49 plus the 189n plus the 237. Expand them inside. At the end, you get 49 over 3 n cubed plus the 56n squared and then plus the 143 over 3. That is the answer for the number 2a. Now we move on to the 2b. Now this question is now the reciprocal the expression. Just now our expression is this. Now they reciprocate it, and you need to use a method of differences to show it. So from here, actually, you should know that when you see this expressions and they ask you to use method differences, we have to use partial fractions. Then you go and find the A and B by changing them into this form. Then you just substitute when the R is this is 8. When the R is negative 1/7, then you will get the A as 1/7. And when the R is negative 8/7, then you get the B as negative 1/7. So from here, we are ready to change these fractions from single fractions and to decompose them become the difference between the two fractions over here, 7r plus 1 minus the 1/7 of the 7r plus 8. So you can see that both of them sharing the same denominator, 1/7. So what we can do now over here is to factorize the 1/7 out to make our job easier. And you put them as a group. This is a one group. Okay. So when the r is equal to 1, you will get 1/8 minus a 1/15. Then when the r is equal to 2, you get 1/15 minus the 1/22. When the r is equals to the 3, you get 1/22 minus the 1/29. And you can see that the pattern of the cancellations will be like this, and it will continue with this pattern until you list them out to the last two terms. It will be 7n plus 1 minus 7n plus 8 for the last term. And the term before that, you know that this will be 7n plus 1. This one will be 7n minus 6. So they can cancel in the pattern in this way. Then therefore, you will get the answer here as 1/7, 1/8 minus the 7n plus 8. Simplify it, you get 1/56 minus the 7 and 7n plus 8. There's no need for you to combine them become one fractions because the question not require you to do so. So you can just leave the answer like this. However, it is okay also if you want to combine them as a one fractions, but over here I shall just leave it like this. Okay, so now we move on to the next questions, C. So C is they want you to deduce the sum when the n goes to infinity. So you just need to write this one down. 7r plus 1, 7r plus 8, and just need to put the expression limit n approach to infinity of 1/56 minus 1 over the 7n plus 8. Just write like this. Then when the n approach to infinity, you get 1/56. Done. This will be the answer for the number 2. Move on. We have a question number 3. One equal to 0. C is a constant and has the root of alpha, beta, gamma. So now the question wants you to form a new cubic equation where the roots are alpha cube, beta cube, and gamma cube. So what you need to do over here is to let the y equal to the x cube. Then from there, we can get x equal to the y to the power of 1/3. So x cube plus the cx plus the 1 equal to 0. It will give you y power 1/3 cube plus the cy power 1/3 plus 1 equal to 0. And you will get y plus the cy to the power of 1/3 plus 1 equal to 0. So you split them, the one with the the power which is a fractions and the one that the power is integer separately. Then after that you cube both sides. So if you power 3 both sides, then this one it will give you -1 minus y cube. So the c cube y, if you expand the right hand side, is actually negative y plus 1 cube. Okay, and if you are using the binomial expansion, then you will get this as the negative y cube plus the 3y squared plus the 3y plus 1. And we want to make the highest power to be positive. So I will get this plus the 3y squared plus the 3 plus the c cube y plus 1 equal to 0. So from here, this is the new cubic equation where the roots is alpha cube, beta cube, and gamma cube. So from here, you know that your alpha cube plus the beta cube plus the gamma cube is a -3. From here, you should know that your alpha cube, beta cube, alpha cube, gamma cube plus the beta cube, gamma cube is a 3 plus c cube. And this one, it will be the alpha cube, beta cube, gamma cube is a -1. You should know all these informations from the new equations over here. So now we move on to the part B. So part B, they want you to show that the alpha power 6 plus beta power 6 plus gamma power 6 is equal to 3 minus c squared. So we just need to know the formula, how to change them into the form that we want. We will make it like this: alpha cube plus beta cube plus gamma cube square minus the 2 of the alpha cube, beta cube plus alpha cube, gamma cube plus the beta cube, gamma cube. So based on the result that we have in the part A just now, you know that this is a -3. Then this is a 3 plus the c cube. Expand, simplify, then you will get 3 minus the 2c cube shown. That is the answer for the part B. And now we move on to the part C. We want to find that the value C, where given that the matrix over here is singular. So if the matrix over here singular, means the determinant of this matrix is a 0. Like this is a 0. So the determinant of a matrix, just apply the formula accordingly. Like this, power 6 this one is the minus the alpha cube, and the alpha cube minus the beta cube, gamma cube plus the b cube, alpha cube, gamma cube. This one is minus the beta cube equal to 0. And if you expand and simplify them, you can group them together: alpha power 6 plus beta power 6 plus gamma power 6 plus the 2 alpha cube, beta cube, and gamma cube. So from the part B just now, this answer from the part B, this is a 3 minus 2c cube. And from the part A just now, this is a -1. So you get the -2 plus the 2c cube minus the 2. So therefore your C, it will be the 4 divided 2 power 1 over 3, which is equal to the 2 power 1 over 3. That is the answer for the question number 3. And move on we have a question number 4. I will make it become a matrix form, -1, 1, 2 for OA, and then OB, I will make it become -2, -1, 0, and OC is a 2, 0, 2. So to find the plane ABC, then I have to have vector AB and vector AC. So vector AB will be the B minus A. It will be -1, -2, -2. Then this one is a 3, -1, 0. And then in order to find the equations of plane, we need to have a normal vector, and the normal vector can be found by using the cross product. So you'll get this one as a -2i minus a 6j plus the 7k. Okay. Then you can find the plane now by having a 4 brackets arranged in this way. This is the normal, -2, -6, and 7, -2, -6, and 7. This is the random position vector, x, y, z. And we have the position vector over here. Choose the position vector A. Then I expand them. 2 minus 6 plus 14. Then I get this 10. Of course, you can also make the coefficient of x become positive. Then you can get this as well. So usually we like to make the coefficient of x become positive. Okay, so this is the answer for the part A. Now we move on to the part B. Find the perpendicular distance from A to B. Perpendicular distance, we have a formula from the plane OABC. So just now the plane equations is the 2x plus the 6y minus the 7z plus the 100 plus the 10 divided by square root of the 2 square, 6 square, and -7 square. Okay, so for this bracket over here, you just need to fill in the position vector for O. Position vector for O is a O 0, 0, 0. So you will get this as the 10 over square root of 89. You can just leave it like this. Then now we move on to the part C. C is to find the acute angle between OAB and ABC. So OAB, you need to take the OA cross the OB in order to get the normal vector for the plane OAB. Okay, so this one is the, if you do the cross product, OA is -1, 1, 2. OB is a -2, -1, 0. And if you do the cross product, you will get 2i minus a 4j plus 2k. There's no need for you to change them to become equation of plane because we only want to find the acute angle between the two planes. So this will be the formula. In order to get acute angle, we put modulus. This is the 2, -4, 2. It will be 4 plus 16 plus 4. And the normal number 1 is the normal that we have in the part A. Is an 2, 6, -7. It will be 4 plus 36 and 49 over here. So your cos theta will be the modulus of 4 minus 24 minus a 14 divided by square root of 89 and square root of 29. So press a calculator, simplify it. I make a mistake. Sorry for that. This is a 3. This is a 3, yeah. My apologies. This will give you a 3. So this will give you a 3. Then this will give you a 9. So this is a 21. Okay. So just press the calculator. Then you can get the answer in 1 decimal place. Done. This is the answer for the number 4C. And moving on, we have a question number 5. Over here, we're following the expressions over here. So what you need to do is you need to start from n equal to 1. When n is equal to 1, you have a dx x psi x. So this one will be product rule. Keep the left, differentiate the right, plus keep the right, differentiate the left. And you see whether it can be arranged in such a form. It will be negative 1 power of 1 minus 1. Then x cos x plus the 2 minus 1 psi x. Okay, so it can be expressed in the form that they mentioned over here. So we just let's say true for n equal to 1. Then assume true for n equal to k. So if n equal to k is true, then the whole statements over here just change the n become k. This is the x psi x. Then this will be negative 1 power k minus 1 x cos x plus the 2k minus 1 psi x. Okay, so this is the second statement. Just say that assume it's true for n equal to k. Now we want to continue with the third statement where the n is equal to k plus 1. So when n equal to k plus 1, you need to show that this statement, all the k become k plus 1 is also true. But however, you have to be careful because when n equal to k, you have a d 2k minus 1 dx 2k minus 1. So when the k become, when the n become k plus 1, this will become d2 of the k plus 1 minus 1 and dx 2 of the k plus 1 minus 1. So this is actually will give you d2k plus 1 over the dx power 2k plus 1. And then from here to here, we need to differentiate 2 times. We have to differentiate 2 times. Then we only can get to the d power 2k plus 1 because 2k minus 1 to go to the 2k plus 1, you have to go through the 2k first. So you have to go differentiate 2 times. So this is something you need to be aware of when you are differentiations over here. So I need to differentiate 2 times. So at the moment, I cannot make my n become k plus 1. I cannot make my n become k plus 1. So what I need to do now is to differentiate this one more time. Now I differentiate this left-hand side one more time. X psi x. Then this one differentiate negative 1 power k minus 1 x cos x plus the 2k minus 1 sine x. So this will give you negative k plus 1. Keep the left, differentiate the right, plus keep the right, differentiate the left. Then this one will be 2k minus 1 cos x. Simplify it, you will get this. Negative x sine x plus the 2k cos x. Now we differentiate. This one will be a d power 2k dx power 2k x sine x. Now I differentiate it one more time. I differentiate this one more time. X sine x will be differentiate d dx negative 1 power k minus 1 negative x sine x plus the 2k cos x. Okay, so this is what I need to do now. Differentiate 2 times. So now the second time when we differentiate the left hand side, now we'll get d power 2k plus 1 over the dx power 2k plus 1 x sine x. Then my right hand side will be a negative 1 k minus 1. Keep the left, differentiate the right, plus keep the right, differentiate the left. And this one is a 2k sine x. Now we simplify them. You can see that this will be can be expressed in the form like this. Negative, we can actually factorize the negative out. Then this one, it will be x cos x plus the 2k plus 1 sine x. So at the end, you can make it become negative 1. This is power k plus 1 minus 1. This is a x cos x plus the 2 of k plus 1 minus 1 sine x. Okay, so this is what you can do. So it's true for n equal to k plus 1. Then conclusion. By the PMI, the d power 2n minus 1 over the dx power 2n minus 1 of x sine x can be expressed as negative 1 power n x cos x plus the 2n minus 1 sine x. Done. This is the answer for the question number 5. Move on, we have question number 6. Number 6, we have a curve C over here is given as the equations y equal to the x cubed plus x minus 1. And the first part of the question is want you to find the equations of the asymptote. So to find the vertical asymptote, just let the denominator equal to 0. You get x equal to 1. That is your vertical asymptote. And we know that we will going to have oblique asymptote because this one is quadratic, this one is linear. So we're going to have oblique asymptote. And then to find the oblique asymptote, you can use long division. Or you can just make it like this. Minus x plus the 2 of x minus 1, then plus 1. Then you can make it become x minus 1 plus 2x minus 1 plus 1. Then you can make the y become x plus 2 plus 1 over the x minus 1. Okay, then therefore your oblique asymptote will be the y equal to the x plus 2. Okay, so that is the answer for the number 6A. Move on, we have a 6B. State that there is no point on C, which is the y between 1 to 5. Okay, so you just need to start from here. Apply to the other side. Rearrange them to become a quadratic equations where the x is a variable and you can assume that the y is a constant. Okay, then you just need to the b square discriminant less than 0 in order to have no solutions or no point. That means your b square minus 4ac will be less than 0. So which means the b square minus a 4ac. So it will be y square minus a 2y plus 1 minus a 4y plus 4. And continue. You can see that you will get y square minus a 6y plus 5 less than 0. You can factorize it. So your y is between 1 to 5. So therefore, point on C. Point on C. For which this one we can write it as a 1 y, the one between 5 lah. The y is between 1 and 5. Okay, now we move on to the part C. We want to find the coordinate of the intersections. Okay, we want to find the coordinates of intersections. Actually, the part B, we found that there's no point between 1 to 5. In other words, okay, in other words, there will be point between y less than equals to 1 and the y more than equal to 5. You will find points over here. So actually, we need to find the value of x when the y equals to 5. So when the y is equal to 5, okay, when the y is equal to 5, we just substitute them inside. This is a x squared plus x minus 1 over the x minus 1. Then you will get x squared minus a 4x minus a 2, plus a 2, plus a 4, sorry, equal to 0. And then you can factorize it. You get x is a 2. Then when the y is a 1, you will get this. So you will get x squared equal to 0. And your x is a 0. Okay. So we also need to find the intersections of the axis. That means the x-intercept and the y-intercept. For the y-intercept, we already let x equal to 0. Now we want to let our y equal to 0. So for y equal to 0, your numerator, this must be a 0. That will give you x equal to the negative b plus minus of the b squared over 2ac, over 2a. Okay. So this is the intercept. Okay, so therefore we have the stationary point. They are 2, 5 and 0, 1. And the x-intercept is negative 1 plus 5 over 2, 0. And negative 1 minus 5 over 2, 0. Okay, so this is the things that we need in order to sketch the graph. So now we are ready to sketch the graph. The graph that we have an oblique asymptote and the vertical asymptote. So the vertical asymptote is at 1. Then this is 2. Two is somewhere here. Then this is negative 2. Negative 1, negative 2. And you have the intercept x equal to 0. Just now x equal to 0, the y is equals to 1. Okay. That will be your maximum. Then another one is that the x equal to 2, y equal to 5. So when the x is a 2, then you have something over here. So you can see that your graph will be like this. Then this graph will be like this. Okay, so this will be negative 1 minus a surge 5 over 2. This will be the negative 1 plus surge 5 over 2. Okay, however, we don't show this value, also doesn't matter. Yeah. But to be safe, usually we will show it. To be safe, just show it like this. This one, I just want to make it become 1 plus surge 5 over 2. Done. This will be the graph for the question number 6C. Now we move on to the question number 6D. We want to sketch the equations of a curve with the y equal to the modulus of the function that we draw just now. So for modulus, actually, it's just anything that is below the x-axis, it will be reflected. So we have a vertical asymptote. We have an optic asymptote here too. Need to draw properly. Then there's a reflection over here. So this is a 1. Your graph will pass through here. This is a 2. This is a 5. Your graph will pass through here. There's no effect, not affected by the one that is above the x-axis. So this graph is the same, not affected. Now the one that is affected is over here. So your graph, it should be like this. Reflect goes up and reflect goes up. Goes up like this. There's a maximum point here. This will be 1, negative 1 plus 5 over 2. This will be the negative 1 minus z 5 over 2. Okay, so this is the graph for y equal to the modulus of x squared plus x minus 1 over the x minus 1. Will we going to use this graph to do anything? Let's take a look at the questions. No more. Okay, the question not require us to do anything with it. Just sketch the graph like this will do. So this will be the answer for the question number 60. And move on, we have a question number 7. Curve with the Cartesian equations given as the following here. And it has the polar, we want to show that it will become the polar equation that r equal to the sine 4 theta. So what you need to do is write down Then this one is the 4xy x squared minus a y squared. So you need to remember that the r squared is actually equal to the x squared plus y squared. So this one will become r squared, power 5 over 2. Then need to remember that the x is equal to the r cos theta. The y is equal to the r sine theta. So over here you will have r cos theta, r sine theta. This will be r squared cos squared theta minus the r squared sine squared theta. So you can simplify them. This one will be the 4r power 4 cos theta sine theta and cos squared theta minus a sine squared theta. You should know that the cos squared theta sine squared theta is cos 2 theta. Then you should know that this one can be simplified to become sine 2 theta. This one can become cos 2 theta. And cos 2 theta, sine 2 theta, we can simplify them again by using the identity. So you will get r power 4 sine 4 theta. This is the r power 5. You can cancel the r, make it become r equal to the sine 4 theta. The reason you can cancel it because the r not equal to 0. So shown. That is the answer for the number 7a. Now move on, we have a 7b. We have the curve C has the polar equation r equal to sine 4 theta, and we want to sketch it for until from 0 to pi over 4. So for these questions, of course, we also need to state the line of symmetry. Okay, we need to sketch the table. We need to draw the table first to plot the point. So over here, we can plot the point. Theta 0. We start from 0. Then maybe we can put the value pi over 24. Then pi over 8. Uh, 3. And then pi over 4. Okay. Okay, so then I think it's enough. We can actually just replace the 0 inside. If you replace pi over 24 inside here, you will get half, 0.5. If you put pi over 8 inside here, you will get a 1. Then after that, pi over 4 inside, you will get a 0. Okay. So you can see that we can start to plot the polar curve. This is pi over 4. Multiplied by 2 bisector, you get pi over 8. This is the theta equals to the 0. Okay. Then pi over 24. Pi over 24 is a bit small here, the angle. Somewhere over here. Start to plot the point 0, and then you get a half, you get a 1, then you get a 0. So you can see that the graph will go like this. Okay, and this is the axis of symmetry. So you just say that the axis of symmetry, the line of symmetry. Okay. We just write the line of symmetry. Is the theta equal to the pi over 4? So this will be the answer for the question number 7b. Move on, we have a 7c. We want to find the area. So to find the area enclosed is actually half integrate from 0 to pi over 4 r square d theta. So it will be r square means that the sine to the power of sine square of the 4 theta. So this one just need to use the double angle formula. You will get this as a 1 minus a cos 8 theta divided by 2 d theta. So integrate it, you will get this one as a theta minus a 1 over 8 sine 8 theta from 0 to the pi over 4. Replace it inside. This one is a sine pi, sine 2 pi minus a 0. So you will get this one as a pi over 16 unit square. This will be the answer for the question number 7C. Now we move on. We have a question 7D. Using the identity sine 4 theta equal to the 4 sine theta cos cube theta minus the 4 sine cube theta cos theta, find the maximum distance of C from the line theta equal to the pi over 2. Okay, so they're giving you this information and this information. And then give the answer correct to decimal places. So that means over here we are having a theta equal to the pi over 2. Over here we are looking for the maximum distance. That means we are looking for x max. So to look for x max, we need to make our r become x. Okay, so to make the r become x, let me erase this. Your r is a sine 4 theta. Okay, you make it become 4, you need to make it become sine cos theta because it's a x max. Okay, so x max you multiply cos theta. So over here we just mentioned multiply cos theta. Then you get this as a cos theta sine 4 theta. Sine 4 theta by using the instructions from the questions. You make it become this cos cube theta sine theta cos cube theta minus the 4 sine cube theta cos theta. So we can make this become x. Then this one I multiply inside, make it become 4 sine theta cos power 4 theta minus the 4 sine cube theta cos square theta. So what you need to do now is to find the dx d theta. So the dx d theta is it's a bit troublesome here. You have a it's quite troublesome anyway. You have to keep the left, differentiate the right. So you get negative 4 cos cube theta sine theta plus keep the right, differentiate the left. And this one is minus the 4. You get negative 2 sine power 4 theta cos theta. Then minus the 12 sine square theta cos power 3 theta. Simplify it, you get negative 16 sine square theta cos cube theta plus the 4 cos power 5 theta plus 8 sine power 4 theta cos theta, and minus a 12 sine square theta cos cube theta. So you can see that these two is having the same expressions. We can combine them together, make it become 4 cos power 5 theta minus a 28 sine square theta cos cube theta plus 8 sine power 4 theta cos theta. Okay. Then let the dy dx equal, let the dx d theta equal to 0. So your dx d theta equal to 0, that will give you factorize the 4 and the cos theta out. Okay. You will get cos power 4 theta minus the 7 sine square theta cos square theta plus the 2 sine square theta, 2 over sine power 4 theta. Okay, so your dx d theta, this will be equal to 0. That means your cos 4 cos theta equal to 0, your theta equal to the pi over 2 is rejected. Then left with the one in the bracket here equal to 0. So the one in the bracket here equal to 0. You have a cos power 4 theta minus the 7 sine square theta cos square theta plus 2 sine power 4 theta equal to 0. It's kind of troublesome over here, but we can divide everyone by cos power 4 theta. Make it become tangent. It will be 1 minus the 7 tangent square theta plus the 2 tangent power 4 theta equal to 0. So you are having a 2 tangent square theta square minus a 7 of the tangent square theta plus 1 equal to 0. You can see that it is a quadratic equations, a trigonometric quadratic equation form where the variable is a tangent square. So we can actually make the tangent square theta over here equals to the negative b plus minus of the b square minus the 4ac divided by 2a. So you get the tangent square theta is equal to the 7 plus minus of square root of 41 over 4. Okay, so you need to split them. Tangent theta equal to the positive 7 plus this. Okay. And then tangent theta equals to the positive. Our tangent cannot be negative because our theta is only until pi over 4. It's still in the first quadrant. So our tangent theta, maybe we just write it as this. Because of the tangent theta is positive. Okay. Then now we need to split them, become tangent theta equal to the positive of this. And another one is that the tangent theta equal to the positive of 7 minus the square root of 41 over 4. So this one, just press a calculator because the form over here is actually quite, the value over here looks quite messy already. We just direct press a calculator, leave the answer in terms of radian. Okay, so your theta, actually we are looking for, what are we looking for actually? Forgot already. We are looking for distance, maximum distance. We're looking for the maximum distance of from the line. That means we're looking for x. We're looking for x max. Okay, we're looking for x max. So we found the theta. Okay, so this data is, you can leave the answer in terms of radian. This data is 0.369. Then you can find the X max. Just use a calculator. Just substitute the data inside. The data X will be quite complicated because the X look like this. Okay, just need to replace the X inside here, the data inside here, and then you press a calculator. Okay, so this one, to save time, I will skip this part. So this one, you just substitute them inside yourself. You get the X max is equals to the negative 0.436. This one, your X max will equal to the 0.93. Okay, so this is not max because this is not the maximum distance. This one you reject it. So your X max will be this. Therefore, your final answer is your maximum distance is 0.93. Okay, they want into 2 decimal places. So we highlight that this is a 2 decimal places. So done. This will be the answer for the question number 7D. And this will be the last question for this paper. So I stop the video here. I'll see you next time, and bye-bye.